All right, geometry students, it is time to buckle up and get ready for Chapter 10, Section 2, Areas of Trapezoids, Rhombuses, and Kites. I love this section. We have a nice little area of a trapezoid formula. Remember, a trapezoid is a quadrilateral. The bases on top and bottom are different lengths, and they have a height from the top base to the bottom base. So the area, all right, let's see how this formula works. We do have a trapezoid here. If you hop it onto its side, you can see, and now it looks like our little trapezoid guy. So be willing to tilt your paper, whatever you need to do to get your brain wrapped around the trapezoid. Okay, so this trapezoid has a base 1 of 205, a base 2 of 511, a height of 309, and we're going to add those two bases together, times it by 309, and then divide by 2. I'll do one time in the calculator calculation for you, just so you can see how that works. So we go 205 plus 511. I hit the equal sign because I don't want 309 to accidentally get multiplied by 511, not the other stuff too. Then we go times 309, and then divided by 2. So our area is 110,622 square miles. So we do the little miles and the little 2 to represent square. Okay, let me put this. Oh, I'll just leave it there. Example 2, suppose the area of the trapezoid is 20. If the height is 4, base 1 is 4 centimeters, what is base 2? So we're going to take a moment and we're going to solve this. Oh, I love me some algebra. I'm going to show it to you. There's a couple different ways you can do it. I'm going to show it to you this way in case we end up not knowing the height, and then you can roll through. We want to think, what's the opposite of divide by 2? Well, that is times 2. We get 40 is equal to 4 times 4 plus b2. The opposite of multiplying by 4 is to divide by 4. So 40 divided by 4 is 10. 4 divided by 4 is 1, and we're just left with 4 plus b2. We are going to minus 4 from both sides, and b2 is equal to 6 centimeters. Yay. Okay, so this is the scenario where you have the area and you want to find one of the bases. So again, recap, we divided by 2, divided by 4, subtracted 4, and got our answer. Okay, rhombus and kite. So you guys, just to talk about it again, a rhombus is a four-sided figure where all four sides are congruent. It is like a tilty square, and in fact, a square qualifies as a rhombus. And then a kite has two pairs of congruent sides, so they're consecutive congruent sides. So this side is right next to its congruent buddy on the right, and then for our other sides, this side is congruent to its buddy right there. So the area for a kite and a rhombus is 1/2 diameter 1, so the measurement that goes all the way from tip to top, times diameter 2, the other distance from tip to top, and that will give you the area of the rhombus and the kite. So let's take a peek. We're given this lovely shape. If you're following me at home, just know some of my numbers got a little separated from their shapes. So this this hypotenuse here is 13. This piece of the diagonal is 5, its other piece is also 5, and then this piece of diagonal at the very bottom is also 5. So we need to first figure out, okay, I need diagonals. I don't have this piece from where the 5 ends and the tippy top of our shape. So if we take this triangle, bump it out, where we got 5 is the side right here, x is this side right here, and 13 is the hypotenuse. We get 5 squared plus x squared equals 13 squared. If you weren't paying attention during Pythagorean theorem, no problem. It's a squared plus b squared equals a hypotenuse squared. So 5 squared is 25, 13 squared is 169. To get x squared, I subtract that 25 from both sides. I get x squared is equal to 144, so I take the square root and find that x is equal to 12. So now I know that this piece of the diagonal is 12. So let's find our two diagonals. One of them is 5 and 5. 5 plus 5 is 10. And the other one is 12 plus 5. 12 plus 5 is 17. Woohoo! So now I can use the formula because I have the two diagonals. Doesn't it seem like such an easy formula? But we got some sneaker numbers that we were missing, so we had to throw a little Pythagorean theorem in there for spice. Okay, so we take diagonal 1 times diagonal 2, and then divide by 2. Half of 10 is 5. 5 times 17 is 85. So the area of this kite is 85 units squared. Okay, let's take it to the graphene level. The vertices of our rhombus are A at -2, 0. Go ahead and plot the points on your graph while we're talking about them here. B is 0, 4. C is 2, 2. And D is 4, 6. We're going to find the area of the rhombus. Woohoo! So we need to find, I'm going to use the straight edge. I hope you feel like it's cheating just as much as I do. So we're going to find this diagonal and this diagonal. To do so, we're going to employ our little buddy who's been in the shed. We're taking this little tool out. We're taking the distance formula out today. So the distance formula says r x2 minus x1 squared plus y2 minus y1 squared is the distance between 2 points. So if I want to find the distance from -2, 0 to 4, 6, I'm going to say, well, this is x1, this is y1, this is x2, this is y2. I'm going to just distance formula the heck out of this problem here. Okay, so we have x2, which is 4, minus x1, which is -2, squared, plus y2, which is 6, minus 0, squared. I'm going to simplify these. 4 minus 2 minus a -2 is a positive. 4 plus 2 is 6. 6 squared is 36. 6 minus 0 is 6. 6 squared is 36. 36 plus 36 is 72. And I'm just going to leave it as square root of 72. You can change it. 72. Hold on. This is 2 times. We'll just do it. Why not? This is fun. Okay, so the perfect square, the biggest perfect square that lives inside of 72 is 36. 2 times 36 is 72. What is the square root of 36? That's right. It's 6. 2 doesn't have a perfect square, so it gets to stay inside. All right, so our first diagonal from here to here is the length of 6 root 2. So now we have to find the second diagonal. It goes from 0, 4 to 2, 2. And we're going to distance formula that as well. So if this is x1, y1, and x2, y2, we're going to fill in that little formula. x2 minus x1, 0. Yes, I love when we have zeros. y2 minus y1. Don't forget the squares. Okay, simplify. 2 minus 0 is 2. 2 squared is 4. 2 minus 4 is negative 2. Negative 2 squared is positive 4. 4 plus 4 is 8. And the square root of 8, well, if you look, what perfect square lives inside of 8? It's 4. Technically, it's 4 times 2. So we take the square root of 4, which is 2, and we leave that other 2 inside. So we have that diagonal is 2 root 2. So let's go ahead and shovel all this into the area formula. The area is 1/2 diagonal 1 times diagonal 2, which is 1/2 6 root 2 times 2 root 2. You can shove this in your calculator and it actually will give you a really nice number. 6 times 2 is 12. Root 2 times root 2 is 2. Half of 12 is 6. 6 times 2 is 12. Ha ha ha, the area is 12. Okay, don't get distracted by the distance formula. He's an old friend. He gets cranky sometimes, but he's manageable. He means well. Okay, example 5. Oh no, there's not even an example 5, you guys, we lucked out. All right, so that's the end of this lesson. You guys are gonna go off and practice these skills. We're gonna get some more graphing this time around. Remember that the area of a trapezoid is base 1 plus base 2 times the height divided by 2. Let me change the view a little bit so you guys can see. There we go. Take a moment, pause this video, make sure you show all your work so you get full credit. And let me know if you have any questions. You are more than welcome to ask them in class. All right, thank you guys.